Hey everyone. I literally haven't played Factorio in like 6 months, Destin. Is that too much for you? I really want to play Factorio again. Okay. Okay. Sorry, I'm just trying to make sure I have everything organized here. Yeah, this is the first reading for complex analysis. So we're following along this book. We're meeting on all of chapter 1. Future meetings maybe we'll split it up because the chapters get a little bit longer. I'm not sure yet, but yeah. This will go a lot like the general relativity reading group, where we just kind of talk about the chapter itself and then go through and solve some problems as a group. I need to bring up my images problems. Okay, nice. Picture's not actually on the table of contents. Why would there be pictures on the table of contents? I don't know. Hey, so 750. Hope you're well. The front cover. Oh, is that normal? I don't think it is normal. I don't know. Okay. I'm gonna hop in the voice chat here. If someone wants to participate in the voice chat and doesn't have the role, let me know. Slim, if you want to be on the voice chat, please do hop in. Um, hey Matthew, same goes for you. If you want to hop in, it's okay if you already know the stuff. I'm learning. I mean, I've seen a good amount of this. I've probably seen almost all of chapter 1 before, to be honest. Um, hey Star. Oh, and Josh, I see you hopped in. Hello. Um, oh, Matthew, is that you?
Yeah, that's me.
Hello.
How are you?
I'm good. How about you?
Quite okay. Actually, it's like 11 p.m. In France, so I'm actually a bit like tired, but
Oh gosh, it's
your
11 there?
stream feels fun. Yeah.
Oh yeah. Thank you for being
Like,
here.
what time is it at yours?
For me, it's 2 in the afternoon.
Oh, okay, like it's great time.
Yeah.
What's the PDF you're on the stream like? It's written?
Um, yeah, the PDF
Okay,
is posted
all
in
right,
the Reading
thanks.
Group channel.
Hmm.
Hey Tyler. And hey Sage. Um, Josh, do you have a microphone or are you able to actually speak?
Oh, Descendant said
Yeah,
like,
sorry.
Okay,
yeah.
nice. Just want to make sure. Um, I the guitar player? No, I can't play any instrument. Don't call sounds with the French accent is next level.
Is Descend Enfant on the Discord chat actually?
Uh, I'm sorry. Is what on the Discord chat?
That is Descend Enfant the one who said like doing complex analysis with a French accent is next level? Is he on the chat, like the Discord chat?
Oh no, he's just in the Twitch chat.
All right.
If he wants to join, he's welcome to though.
Yeah, because his username is French actually, so he might be French too. Like he
I
have
think it's
great
apparently a thing in
French
math.
audience.
I don't remember where he's from, but I'm not sure if he's French. Um, he's not. He's saying he's not French.
All right, all right.
I see we have Slim and Penbox here too. Hello to the both of you.
Hi.
Hey Fizzbuzz. And Slim, if you're talking. Oop. Still can't hear you if you're talking, Slim. I wonder if he's having tech issues. Okay, at least in the meantime, for those who are new, there's an Excalibur link where it's like a whiteboard that we can all like collaborate on. It's posted in the text chat along with this group chat. So you have to like hover over the channel and there's like a little open chat icon. Hopefully Slim is able to get things fixed.
All right.
Okay. Maybe we can just get started talking about it. I was hoping to wait for Slim to figure it out, but hopefully that'll happen soon enough. Have you learned what the contour integral of Western Europe is yet? No. Is it a meme?
It's 0 actually because it's closed.
Oh, well, okay, yeah, I guess it depends, like, I guess you're going, like, all the way around, like, Spain and France and Portugal, and you, like, come back around. I don't know. There's no polls, okay. It's the delay from Twitch to Discord gives an echo. You're gonna listen. Okay, Slim, if you're able to get it figured out, you're welcome to, like, speak too, but it's up to you.
Okay, then what's the contour integral of Eastern Europe?
Apparently it depends how many polls there are. So yeah, I guess maybe for the group, I'm thinking like approximately 2 weeks per chapter. I'm not sure. Chapters 2, 3, and 4 might be a bit bigger than chapter 1, so we might need to extend it out to 3 weeks or something. But at least for chapter 1, I'm thinking spend about 2 weeks, including this week. So yeah, how we normally start off with this is we just kind of, since we're saying we're meeting in chapter 1, we just kind of start by talking about the actual kind of like content, if we had any questions or anything we found interesting. I gotta say, overall, as a writing style, this book is very dry and academic and boring, in my opinion.
Yeah.
But I think they're gonna hopefully get at some interesting ideas here anyway.
I'm sorry, I'm still a little bit new here. How far have you guys gone on the book on your own? Because I thought I was under the impression it was like only chapter 1. At what point did you guys end on?
So hopefully by this point we've all read through all of chapter 1, or at least have familiarity with it from somewhere else, like the stuff that it covers. So just basic things about complex numbers, and then a couple things like limits and stuff.
Okay.
Well, the goal is to get through like chapter 4 or so, but for now we're just on chapter 1.
Yeah, chapter 5 is like a bit advanced, I think, like So yeah, chapter 4 is like the well, the greatest you can like do it
Okay.
clearly.
I hadn't actually looked at it. I just saw that chapter 4 was contour integrals. So I was like, oh yeah, it's probably a good goal. um, yeah, I think personally I was mostly familiar with pretty much everything in chapter 1. There were a couple of interesting little bits that jumped out to me, but I'm trying to find them again. If there's anything they want to say, please do. Um, I felt like a lot of their proofs were a little bit like lazy, or at least like very short anytime they were involving epsilon delta stuff.
Yeah, because they suppose we're following like real analysis course, and it's like the same
Yeah,
pretty much.
that's fair. I guess I don't remember how I know I've learned this before, but it kind of I don't remember how I thought about it, because the limit definition of a derivative, you have, at least in the first version, I'm looking at page 23 here at the bottom, equation 1.3.9. It involves an f of z naught plus delta z minus f of z naught over delta z. The idea of a delta z is kind of weird to me, because there's different directions you could have a difference in, and they don't
Yeah,
really explain that.
you're absolutely right. Like being differentiable like in all directions does not imply being differentiable in the complex meaning. In the complex meaning, it means like basically you have the same differential in every directions. Basically, like if you do like the point of view of differentiation, like writing the differential. How do you say differential in like English? Sorry.
Like derivative, or
No, no, no,
like
not actually
so,
derivative. Like, the differential is like when you write some function as like, say you want to compute f of z plus h, where h is small, then f is differentiable if and only if you can write f of z plus h equals f of z plus something called the differential of f at the point z, evaluated on the direction h. And the application differential at the point z must be a linear application, okay? So like it must be some matrix, say. And so being differentiable in the complex meaning, it means that this differential, this matrix, is actually a similitude matrix, meaning uh, is the composed, it's like the product of some rotation matrix and some scaling matrix. I don't know if you see.
oh, I that's new for me.
And so being differentiable in the complex meaning, it means a really rigid definition of being differentiable. It means that your matrix of the differential is actually um, the product of a scaling matrix and a rotation matrix. So it's like very rigid. This is why we have so much big theorems on differentiability. Is because on complex differentiable functions, is because like it's so rigid that you have to have, let's say, your integral equals 0 on closed surface, on closed path, and so on.
Wow, yeah, that'd be really interesting to learn about that interpretation of a derivative. Um, this is saying like a conformal mapping or matrix decomposition from each step. That's what it sounds like, yeah. Quinter, thank you for the follow.
Yeah.
Oh, nice, Snoop. Okay, so I'm looking through. Oh yeah, there's one very tricky limit. Equation 1.3.18 on page 26. They have this, they end up with a limit of e to the delta z minus 1 over delta z. And the equality in the middle was very difficult for me to figure out like what's happening here.
It's really what the fuck, like.
Yeah. And so I think you kind of split them into like a cosine delta y minus 1 over delta y, and the x's aren't important for the limit, and then you get a sine delta y over delta y, and the x's aren't important for the other piece of the fraction. But that one I had to like write out separately and figure out why this would possibly be 1.
Did you figure it out actually?
Um,
Like you saying you had troubles figuring it out?
I think I have now, and I think I picked out a problem that does it with polar. So we'll hopefully get to that at
Yeah,
some point too.
definitely. Yeah, but like in complex analysis, you don't oftentimes go back to polar because like going back to polar is like quitting the complex word, going back to like R squared word, and like you don't have so much theorem on the R squared word. You have more theorem on the C word, like if so to say.
Interesting. Okay. Hey, non-dairy neutrino and MMD. Yeah, I think you're right. I guess we can I can like screenshot and I can bring it over to the Excalibur. Oh, you're that Quinter. Awesome. Welcome in. Yeah, that was super fun. Hope we can do it again. Okay, so if anyone can't find the Excalibur, let me know. But I just dragged in a screenshot of the limit in particular. And so how I thought about it is like from that step, we split up into 2 different fractions, like the real part and the imaginary part. It's not so clean because there's an I in the denominator, but I still split it up like this. And I didn't do it too intensely after this point, but I just kind of figured, sorry, my phone is blowing up right now. If delta x is going to 0, then the delta x in the denominator isn't too important, and the e to the delta x just is going to 1. So you only really have to care about the cosine delta y minus 1 over delta y, and we can just pretend that's a known limit that goes to 1, like sine x over x. And I think I use the same logic over here, where I just kind of assume that the e to the delta x up there and the delta x down there aren't too important, so we just care about sine delta y over delta y, and that's another known limit that goes to 1.
You're right.
Okay.
But like, does the book like defines the exponential in terms of like its Taylor series? Can't see, right?
That's a good question. We need to go back and remember that piece. They define it as cosine plus I sine, it looks like.
All right. That's why they do like all this stuff with the cos and the sine, like because they define it like geometrically.
Yeah, I always assumed that the series definition was the common one. But maybe they have a reason for that.
yeah, the multiples definition, like it depends like on your taste.
Okay. MD, yeah, like the definition for e to a number.
All right. Okay.
Um, maybe in chapter 2. Yeah, I mean they might like define it again or like switch to a different definition. I guess that's always possible too.
Yeah, thanks, dude.
Um, yeah, I don't think I had too much else to say about chapter 1. They said they were introducing it later, MD says. Oh, okay. Thank you for that, MD. Um, I'm just quickly scrolling through it, trying to remember if I had any other questions or weird things that I wanted to point out. You don't need it to be analytic to define that. Okay. Hey, Jesu. Okay. I guess maybe the only thing I thought that was weird was in section 1.3.1 where they talk about differential equations. They make the point that t is constant, the variable we're taking derivatives with respect to, but they don't really say anything about w. And I assume w can be a complex function, but I was just kind of like weirded out with like, why are we doing complex functions of a real variable? I assume this makes it so it's like regular differential equations that like someone would already be familiar with prior to learning about complex variables.
W is like random analytic function, isn't it?
I guess so. I'm kind of assuming it can include complex numbers. 'Cause I think they use w for that purpose somewhere, like earlier.
Okay.
But yeah, that part is kind of weird. Where like they force t to be real, but they don't say much about w. So
Yeah, it's analytic because like they're saying basically if you want to solve a differential equation
actually,
with
I do see.
analytic functions, yeah.
Yeah, w is an exponential to a complex number. I just noticed that now.
Well,
Or like
it's not
it's.
always the case.
I think they're just making it. They're taking a simpler case.
All right, okay, okay, yeah.
But yeah, I don't know. That restriction felt a little bit like weird, but I assume they made that just to make it
Yeah,
simpler.
because like you have both way, like you have two ways of treating this like differential equation. First one is like you have a recurrence relationship on your coefficient. Like if you have say like a order 2 differential equation on W, then you're going to have like a order 2 recurrence relationship on AN, the like the coefficients, and so you have to be able to like solve this this relation this recurrence relationship. And if you do it like with exponential z of t, then like you're basically you're at the same time solving the differential equation and solving like the recurrence relationship like in one step instead of two.
Okay.
Provided you find like roots to this like big equation on 1.3.21.
Okay. Yeah, I definitely seen the calculation before, just not necessarily with a complex variable like bend to it. I've seen it a little bit, but like it wasn't emphasized. Phobos, hey, thank you for the bit. Hope you're doing well. MMD's asking about the pendulum differential equation. Yeah, I'm pretty sure it might just be the one that I happen to be looking at right here for simple harmonic motion. Yeah, so that's like a neat little application. Okay, I think that's everything I have to say about like the kind of content of chapter 1. Does anyone else have anything they want to like bring up before we get into solving problems?
Nope.
Okay. In that case, so I picked out some problems from throughout the chapter. If anyone wants to suggest one, please do. But the first one, I didn't choose any from section 1 because they looked a little like maybe like simple. So starting from section 2, the first one looked interesting to me was number 3, which I'll bring into the Excalibur. Let me make sure it's not overlapping stuff. Okay. So we use Euler's formula for the exponential and the well-known series expansions of the real functions e to the x sine of y and cosine of y to show the power series for e to the z. And they're suggesting we use this binomial expansion formula. And that hint feels a little bit weird to me because I've definitely done this. Like, or I guess this is e to the z. I've done it for e to the x equals I sine y plus cosine y with power series. But I guess I haven't done it for e to the z, to be fair. Smells like a power series? Yeah, an MMD.
So are we trying to show that like this is equal to something like this?
Yeah, I think it's a good thing to think about. And that might be where we want to use that binomial expansion. I guess we could get a double summation though with that.
We try it.
Definitely, it's gonna work like what you're proposing.
Well, okay. I guess we can try it.
Definitely.
So
If you're courageous enough to like expand it, it's gonna work.
uh
Hey, Bob. I think we're supposed to do something a little bit weirder, but there's a little bit of a weird feeling to this problem.
are we supposed to do something different?
No, I should be. I think this is probably what they intend for us to do. It's just a little bit weird. Yeah, this looks okay to me so far.
Where do we go from here?
That's a good question. Someone's saying it'll work. We need to recall the product formula thingy.
Maybe we could just use some other variable. Like we'll say m equals k minus j, and then we can end up with like a single sum here.
But like the thing
Or-
is, just to like we already did binomial expansions, so like we won't do it again. Like to me, you have to like flip introvert like the two summation.
Slim is saying that we need to use the Cauchy product, which is a new thing for me.
Cauchy product?
It looks like a way of splitting up series, maybe with a similar idea of what you just did there, Josh.
Yeah,
That's what the Wikipedia article says. I'm still trying to figure out what it exactly means.
yeah, I think that would work as well.
Yeah, but basically you have to like identify what goes to where.
We would have yeah, Cauchy product is actually probably a cleaner way of doing this. I think it would work out better.
Get the exponential of the real part times the series or
We
sine
know
cosine.
like e
Yeah,
to the
we know
x.
where we're trying to get to. We're trying to find a sine and
equals-
cosine.
Because we already know this and this. So I think we could use. I think that if we like take these two things, we multiply them together. We could probably show with Cauchy product something like that.
Oh. Yeah. Because I see like on the right side of the Cauchy product, there's like an A sub L and a B sub K minus L. And I think we could split up, yeah, the thing that you have on top there with like J and K minus J. Okay.
We want to try that?
Yeah, I think that's our best bet. Hey, Molly Denim. Welcome in. I guess, I'll, fill it in. Oh, you know what? We do have a K up for the second summation, and these are supposed to be... Do these need to be infinite? I'm just looking at the,
I'm not
someone's
sure.
saying it's fine. Okay, I'm not completely clear why, but that will be convenient if it is. C sub K is the internal.
Okay.
Oh, maybe I'm misreading this. Should there still be...
Yeah.
Okay.
Okay. I see what he means.
Well, does that mean the... okay, now I'm... Does the K summation still exist on the outside? Okay, yeah, this one is finite. Oh, this is a double sum. Oh, I get it. Okay, this is just weird notation. This is a double sum here. Okay. uh, this would be like, I guess this over here would be x to the k over k factorial. Then the other one would be freezing j equals 0 to infinity. Oops. Iy to the j over j factorial, because the k minus j becomes its own index. Okay, the thing I didn't understand is that the right side of the equation is an infinite sum with a finite sum inside.
It's weird.
Yeah.
That's weird notation too.
Yeah. But that does get us where we want to go, using the fact that you wrote in the bottom left there. So that's e to the x times e to the iy, which is just e to the z, and that's what you wanted to prove.
That's what yeah. Okay.
Nice. I think there's a lot of different ways to do the same thing, but that's a way that I haven't seen before, at least.
Yeah, I was going to do another binomial expansion after that first one, and see if I could try separating the double sum. So whoever brought up Cauchy stuff in chat, thank you.
Yeah.
I think that's a lot cleaner of a way of doing it.
Wait, we want to expand the second series into a series of sine and cosine. Do we want to do that? That would just be for funsies. Do we solve a problem because j only goes to k? No, it works because j only goes to k.
So right here is where you had to use Cauchy product.
Yeah, it's fine
Yeah.
because you're using it inside of another infinite sum, so that becomes a double sum over k and j, and you can just switch the order of summation if you need to.
Jess was right. The question does say to use the series for sine y and cosine y. That feels kind of annoying though. I don't know how we would use it. Like, presumably we'd use it with the iy to the j, or like that like j series. But I don't see exactly. Oh, I guess you split them into an even and an odd part. I feel like this is fine though. I'd rather just do it this way. I think if we want to be really strict with what the question was asking though, we could make that I to the j look more like an alternating series. Or it's like we go by the even and odd indices and find a series for sine and a series for cosine.
Maybe they're saying like even before we even start doing these steps here, to start off completely different.
Be a lot more annoying with double summation involved.
Yeah.
Doing it differently will be harder, but you also get there. Okay. I mean, I'm pretty satisfied with this. For bonus points, we could really go down the rabbit hole and make the sine and cosine y series show up, but I feel like we're okay. But I don't feel the urge to do that personally. We don't do things for funsies. Okay, that's everything else on 3. I'll bring in the next one that I found. The next one that I saw, which was 4. Bringing it down below here. Okay, so Using series representation we just found, determine the series for the following functions, sine of z and cosh of z. Use these results to deduce where the power series for sine squared and hyperbolic secant would converge. I guess starting off with part A though.
What's
I mean-
sine z? It's like e to the z plus e to the minus z over 2. Is that what it is?
Oh, that's probably what we're supposed to do. Yeah.
Sorry. Could you repeat that?
Sine of z, is it? I think it's 1/2 of e to the z plus e to the minus z.
Yeah, so it'd be e to the iz minus e to the negative iz over I. After that.
E to the iz minus e to the minus iz over 2i. Yeah.
Oh, I forgot the i's.
Series for life. Thank you for the follow. You came at a good time. And hey, X Shanya.
We could just plug in the power series for this, right?
Yeah.
So we would get e to the iz equals actually, I'm going to is there a eraser tool?
It's the number 0, or you can like drag a box
Okay.
around it. Yeah.
So instead of doing this, what I'm going to do is I'm going to say sine z is equal to 1 over 2i times
Oh, okay. Yeah.
this. And I'm going to also do this. Does this follow?
Looks good to me. Yeah.
Seems good.
And because all the odd powers survive, then we could just say sine z equals. I'm wondering, are you using a pen to write your notes? Because they look a lot better than mine.
Yeah. You're doing pretty well though. That's just your mouse.
I think that would be it for A. And then B would basically be something really, really similar, just with Z. It would simplify a lot easier.
I'm cheating with the
You would
pen.
just have Z to the n minus, or actually plus negative Z to the n. So for B, it would probably, the same thing would be here, just without IZ, and it would be what, like Z to the 2n over 2n factorial? So
There's analysis issues with the manipulation from part A, but they apparently work out. It's interesting. I didn't know that. I just realized that Matthew dipped. I wonder if he went to bed. I want to blame him. Oh well.
and this one simplifies a lot easier.
MD, yeah. I'm gonna post the image of these notes in my Discord once we're done.
Okay,
Okay.
now you use these results to deduce where the power series for sine squared z and secant c would converge. What can be said about tan z?
Hey, Pui, Ika, is this really that complex? I don't know. Does the series for sine z? I assume that converges everywhere, right? For all z. So it's
Yeah,
just a piece of e
and
to the z.
it's still entire. It still converges everywhere. But for hyperbolic secant z, the only issue is poles where it would be equal to 0. So we would have to check for that, I think.
I think
Unless I'm
hyperbolic cosine
missing.
is never 0 though.
Yeah, we could check. No, it would. Let's prove it, because I think is it never 0
I, um,
for
oops.
complex?
Oh, of complex. That's good. I was thinking of just in real numbers.
Um,
uh,
well, we could just try
how
to
do we
prove.
do
I
this? Yeah.
can see. So we're gonna have hyperbolic cosine of z equals e to the z plus e to the negative z over 2, which is going to be equal to 0. Which is equal to 0.
Hmm.
E to,
I mean, e to the z.
e to the z equals e to the negative z would be, okay. So we would have to have e to the negative 2z, or actually e to the 2z, I mean, equals negative 1. That would make that true, I think. So then z so that,
E to the z is -1. Oh, okay, I can see that.
yeah, yeah, for up here to make that true. So
And I guess
I guess we could just simplify for z, right? Figure
yeah, it
out
should just be like
for what values of z
number.
does ck z. So it's just gonna have poles at like plus or minus pi I over 2, plus or minus 3 pi I over 2, that sort of thing.
Okay, yeah. So we're saying it converges everywhere except those points, I guess.
Yeah. It has a radius of convergence, which is equal to the distance to the nearest pole, which would be absolute value pi I over 2, which would just be pi over 2.
Okay, yeah, I never had to think about the radius of convergence for a complex series. That's good to know. That's like they go by the nearest pole. They're also asking about tan z for that convergence. I guess that's we have to worry about where cosine or sine over cosine. Yeah, so where cosine is 0.
Yeah. For this one, I think the process is the same thing.
Then let's. Well, we really just care when cosine z is 0. And cosine.
It's 0 at pi over 2 plus n pi. So.
Right. Well, for real numbers, but there are also complex numbers where. That's just what I wanted to like make sure.
Cosine of a complex number? Is that ever equal 0?
No clue.
Does anybody in chat know for a fact if cosine of a complex number is ever equal to 0?
Trying to figure it out using the same process you did there. So 2e to the iz is minus 1 now.
Well, yeah, I mean cosine of pi over 2 is 0, right?
Yeah, but for
So-
outside of the real numbers, like for the complex numbers where we just have like the real part, pi over 2 plus n pi, all those numbers would be equal to 0. But are there any other weird complex cases where that happens?
Actually, I'm looking at a book here. It says cosine z equals 0 if and only if z equals n plus 1/2 pi. So basically pi over 2 plus
N
an
pi,
integer multiple of pi. Yeah.
So I guess it's never equal to 0. We should still prove it though. Be rigorous, right?
I think it is only 0 at real numbers. Did I get the right thing? Something about this feels. Pi over 2 plus n pi. Why am I getting this wrong then?
Okay. Let me take a look.
Hey, Anju. Colded, I'm not taking questions right now. I'm not sure how you do that question either.
So you have e equals negative e to the iz, e to the 2iz equals negative 1. Iz equals negative 1. So I think that these last two might be wrong, because where I would go with this is I would say 2iz equals
Oh yeah,
pi
the 2z
I
should just be pi, not
plus
3 pi over 2.
It should. Oh, yeah. I don't know why I said 3 pi over 2. Where's your problem?
oh.
By your problem, I mean my problem. Okay. That gets that result.
Josh, I think you were saying the same thing,
Yeah.
basically.
Yes.
But yeah, so then there's no complex cases where we get poles.
Okay. Puig is saying that cosine z is equal to cosh of iz, so there's a one-to-one correspondence between their zeros.
Okay.
Do these look the same? Left side's an
That's a
I.
much better. That's actually
Yeah.
a much better way of doing that.
Yeah, that's a neat thing. The zeros are the exact same, just the cosh is an I with it. Nice, Puig. Thank you for pointing that out.
Just when you thought there were a lot of trig identities, now we're going to get more with complex.
Yeah. Okay. Nicely done, number 4. Next on the list is number 7. These are all from section 1.2 so far. Brought it in down below here. Discuss the following transformations, mappings from the z-plane to the w-plane. Here z is the entire finite complex plane.
So u equals z cubed and w
That cosine
equals
is a
1
power series given
over
by
z.
complex conjugate. Ooh. Probably finishing another way of thinking about the zeros of cosine. Power series given by real You can use the fact that cosine has power series given by real coefficient, thus zeros must be fixed by complex conjugate. This is equivalent to say all zeros are reals. This works for any power
This
series
chat
given by real
is
coefficient. Sorry,
this chat
what?
is a lot smarter than me. I would never think of doing that.
Yeah, that's what Chad does. They say smart things.
We kind of brute force proofed it. That's a lot more elegant.
Yeah. For part A here, it seems natural to me to think about the polar form of this.
Yeah. In polar form, the magnitudes would get cubed and then the angles would triple.
Yeah, so maybe
Yeah.
they just say to discuss it. So that's not a very high bar, but we can maybe draw some example points. So like the point like 1 plus I. Oops, that's not 1 plus I. That would get mapped. Well, the radius is, maybe I should have chosen one with radius 2, or radius 1, but the 45-degree angle will get tripled. So I think, are we going to end up just some...
No, we're gonna end
No,
over
over
here.
Over there? Oh, you're right, yeah, okay. I don't know basic math. And then we're going to extend out, like, tripled out lengths, like, somewhere over there. I haven't done the actual... calculation.
And the unit circle will be fixed.
The unit circle is fixed. Oh yeah, for the magnitude, at least.
Yeah.
And so there's an interesting breakpoint there with the unit circle where exactly on the unit circle, the magnitude doesn't change. Outside it increases, but inside the unit circle, it actually, the radius gets smaller.
Yeah.
So does it not change?
Oh
yeah, magnitude gets cubed and not tripled. I don't know.
Oh yeah, cubed. I don't.
Yeah, so it just stays.
Well, this is magnitude root 2,
1.
so it's root 2 cubed now.
Oh, root 2 cubed. We should have done magnitude with 1. This
yeah. I mean, I think it's good to get all 3 types of cases.
Yeah.
Circle decreases.
Oh, so it got doubled.
Does it get doubled?
Well, root 2, a magnitude of root 2, when you triple it, will get doubled. When you cube it, I mean. It's just kind of a
2
coincidence.
cubed is 2 root 2. Okay, so cubing it is doubling it.
So it would just be 2 root 2.
Yeah,
Yeah.
for the length. Nice.
I think it'd also probably be good to point out there's a critical point at z equals 0 where derivatives vanish.
As in not differentiable at 0?
Yeah. It's conformal everywhere else. Like it's angle preserving everywhere else, just not at 0.
Okay. Yeah, the book must talk about that somewhere like later on. Then that's good to know, though. At least I didn't know that. Okay.
There's 3 fixed points, 0, 1, and -1.
0, 1,
I don't
negative
know if
1.
that, I don't know if that matters.
That's probably interesting to. I guess you get that by solving z cubed equals z.
Yeah.
Okay, yeah. I don't know if those are important, but they're good to note.
I guess it's really not important, is it? Because if you're at a fixed point, that's pretty cool. But if you go a little bit off of a fixed point,
Oh wait, negative one
like all
shouldn't
bets
be
are off.
fixed. What did you say? Shouldn't.
Yeah, I said 0, 1, and -1.
Oh wait, no, negative 1 is fixed. I'm sorry. Yeah. Sorry, Anju. We're just doing questions from the book, not from chat for now. Okay, so unless anything else on part A, maybe we can go on to part B. Reciprocal 1 over z.
That's a
What
Mobius
else
transformation,
should we
right?
say about?
Oh, is there
Is there
anything
anything
else?
else worth saying about z cubed?
Not that I can think of.
It's 1 to 1, right?
1 to 1. I would believe it.
Yeah.
What about points on the unit circle? Because I know they stay on the unit circle.
They would just rotate around.
Yeah.
It's 3 to 1.
I don't think it is 1 to 1 because yeah, it's not 1 to 1, is it? Because -1 lands on -1, but like you got another point that's like 1/3 of the way around that's going to land on -1. So maybe it's 1 to 1 as long as you're not on the unit circle.
Yeah, so it's not 1 to 1 then.
Oh. Okay. Funny, it's only 1 to 1 sometimes.
Yeah. I guess in like most applications of this, you would have something where when you were defining a point, you would have like first your I, and then you would multiply it by I afterwards, and your rotations would be here. So you would still, even if you had -1, you would still be able to rotate around.
Yeah.
Here, I guess not. Should we move on to the second one now, B?
Yeah.
Both really freaking fun and really freaking unfun. Hey, Lucas. Yeah, for B. Oh, wait. Clarkon, are you saying it's not 1 to 1 anywhere? There's always three distinct solutions. All right, see you, Lucas.
Oh, yeah, I like that. Thanks, Kyler. I agree. That seems right. Because you can always take your angle and cut it into three,
Yeah.
like trisect it, can't you? Yeah, okay. Okay.
Okay. Yeah, that makes sense.
That's nice geometry if you know about Riemann surfaces. We've learned about like the Riemann sphere. If that means something else that I don't know about it.
Oh, I got a friend who's really good at geometry. He would go crazy over that stuff. But I've got not a clue about it.
It's like Connor caught the one-to-one thing as well. Okay.
You can take any solution and multiply it by a root of a unity to get another solution to z cubed equals w.
A cube root of unity. Okay. Yep.
Wow.
So that, wow. Yeah.
I think I can picture that in my head.
Yeah, yeah.
If you're multiplying by a cube root of unity, you're just adding to the angle.
So,
Yeah, it's kind of like rotating around the origin through 120 degrees or 240 degrees.
And no matter what, it's
Or
going to get
360
tripled
degrees.
anyway. Okay.
it's awesome.
Yeah. Thank you for pointing that out, color code. Okay, now is there
So
anything
the
else for
other
z cubed?
We have,
Okay, yeah.
I'm gonna get started on the other one. If anybody wants to come back to z cubed, please do, because that's interesting.
It's a pretty open-ended question, just discuss. So we could discuss it for a long time.
Or we could discuss it with like one sentence.
Yep.
Yeah.
That negative exponent is interesting. It makes it look like a reflection. Or if we're negating the angle. It's like we're reflecting across the x-axis,
no,
maybe?
So magnitude would invert w equals 1 over z, right?
Mm-hmm.
Yep.
Angle would reflect, right? The angle would just go negative.
Yeah.
So, oh, there's a similar thing with the unit circle, where
So the unit circle itself would just map to itself, but the inside maps to the outside, and the outside maps to the inside.
yeah,
Okay.
And it would flip across the real axis, so you would reverse orientation.
versa. Itself. Let's get reflected. This is across the imaginary axis. I can
Oh
move
my
this
god,
text
there's
out of
arrows
the
in
way.
this program.
Yeah.
This is a really cool program. I can't believe I've never seen this before.
Eventually it's going to get not so cool. Once you put too many things on it, it'll start to complain and get laggy. But other than that, it's really awesome. I like the site a lot. Connor, yeah, people are saying that this is a Mobius transform of some kind.
Yeah.
I'm trying to know if you have polynomial p and you want to solve p is equals w. There is given by degree n. Oh, yeah, color code. I should have thought about that. Okay. That's related to part A, where if you have something cubed, there should always be 3 solutions. The analog function is conformal, angle preserving at a point where its derivative is non-zero. Okay. And Connor was saying specifically that 0 gets sent to infinity and infinity gets sent to 0, which I think is good to be said. But I think we've kind of, this one seems a bit, I don't feel the urge to actually like draw anything out here. I feel like I can just imagine it.
Yeah, you said that you knew about the Riemann sphere, right?
Yes.
So in the extended complex plane, which is Riemann sphere, this would just swap 0 and infinity.
Okay. Like it basically
Same
like turn
idea.
it upside down.
Yeah.
Okay. Neat.
And
Or anything else for number 7? I'll bring in the next one.
Just not 0. Are we gonna do a go in depth with this as we did with A?
Oh, I mean, I thought we did go in depth with this one. What more should we do with it?
Conformality, I
Um,
guess.
I guess the book hasn't gone into that. If you want to talk about it, though, feel free. I wouldn't be able to help with it, though. Or I don't know anything about it.
No, it's fine. We can move on if you would like. Other
Okay.
people in chat were talking about that sort of stuff for the first one. But I also don't want to spend too long on this one. It looks like, I think that it's mostly trying to get us over with just how the translations work with it, swapping the inside and outside of the unit circle for this one and for the first one, just like how the rotations and the radius would change. That's what I
Yeah.
think it's trying to get at.
Yeah. Quick is saying any Mohs transformation is like a rotation on the Riemann sphere. Okay. All right. Speaking of Mobius transforms, I think I'd recommend the next question as being a Mobius transform without actually naming it.
So wait a second now.
Oh, okay, before we get into
Did you
9.
did you say did you say that 1 over z? Did you say this was, if we thought of this in terms of the Riemann sphere,
Yeah.
did you say that it was like making the North Pole into the South Pole or something? I think I didn't understand what you said. I understand that it's mapping 0 to infinity and infinity back to 0.
That's what.
Sorry, what? Could you repeat that?
Yeah, so 1 over z, I mean, if we think of it as the stereographic projection or whatever, so the North Pole of that sphere is going to get mapped to the point at infinity. And the point at infinity, I guess, would get mapped back to the North Pole. But I thought I heard you say something about we could think of I thought I heard Don say we could turn the sphere upside down or something, but I might have misunderstood.
I think it is turning the entire Riemann
So,
sphere upside down, not just the two
like,
poles. But go on,
you
Josh.
can imagine the unit sphere, right? It's floating above the
Yeah.
complex plane, and
Yep.
the South Pole touches the origin, z equals 0,
Yep.
and the North Pole is at infinity. For this, it wouldn't flip it, but it would invert its orientation. Stereographic projection, it preserves angles, but it's not related to size or difference. So you just kind of get an inversion effect. Everything near infinity just compresses down to a point.
Okay, and so this inversion is sort of, it's another way to think about sort of the inside of the disk getting mapped outside and the outside getting mapped back inside.
Yeah. It's not. It's
Okay.
more accurate to like imagine the complex plane gets turned inside out rather than flipped upside down.
Yeah, okay, okay.
Maybe I'll remove that last sentence that I wrote. Because it may be a little more subtle than I was making it. But I thought there's a thing with Riemann sphere where the unit circle maps to a certain region of the Riemann sphere. Like the lower half. I mean, well, I guess it wouldn't be the lower half, but that's what I was imagining. There's an actual, like, the entire thing being flipped. But now I think about it, maybe the unit circle isn't so special on the Riemann sphere. I don't know. There's something there, but I'm not sure how to phrase it. Unless someone wants to harp on it, we can move on.
Yeah, we can move on.
Okay.
Okay, consider the following transform.
So yeah, number 9. I think it's like the general version of a Mobius transform, but the book hasn't like named it yet.
Yeah, it is.
Okay.
So the first thing is to invert it. That would be the first step.
The unique. Yeah, so I guess we.
Basically just solve for Z.
I think so.
Yeah.
Yeah, okay, well,
All you're doing is solving for Z here.
we all got that.
I'm weirded out because there's 2 Z's. That's what I don't immediately see how we're gonna deal with that, but I assume something will factor out.
Yeah, you just get all your Z.
Yeah, when you
Z's on
bring
one
all your
side,
Z's
you
to one
factor.
side.
Yeah.
WC Z minus A Z. I'm doing the dangerous thing of mental math in my head. B minus W.
Alright, that's all right. We're watching.
D. Okay. I think then we're factoring the Z out and dividing everything over.
WC minus A. And as long as WC minus A is not equal to 0, then we're all good.
Okay. Thank you, Kawarko.
And this makes sense. You can imagine it's valid everywhere except where the denominator blows up, and that would map to infinity on the Riemann sphere, if you can imagine that.
Okay.
So, yeah.
And Puika was saying that it's basically a rotation on the Riemann sphere, which I hope Part B is gonna get into a bit, or that's something where I would need to see a bit more about it to feel like I understand that.
I believe they said, sorry, the above is not actually true.
Oh, never mind. I forgot that.
That's
Right, I
like
can
that's
read
more
that.
like a generalized sense. It's like it corresponds to a conformal automorphism. So that's any kind of angle preserving bijection of the Riemann sphere. And they're kind of like sphere rotations in the complex plane, but more precise. I mean, the book will probably talk about it later. It's a very big generalization to say that any Mobius transformation is a rotation on the Riemann sphere, but it's accurate for the most part intuitively.
Okay. What's up with Part B then? Verify the mapping can be considered as a result of 3 successive maps, where C not equals 0 is the form. Wait, so we're taking a complex point Z. Okay. We're multiplying it by a number, adding another number, and then we're going to invert it. And then whatever the hell this is. Delta? What is delta supposed to...
That's the determinant they set up here.
Oh, thank you.
Oh, kind of like a determinant, I guess.
Okay, I guess we're gonna take our point Z and track it through all these different things.
So this is where we start. And I guess for this, I would just invert this. So
Yeah, flip it over.
and then after this, we will apply the final linear map.
Yeah.
So
Oh, I see. We're going by cases here, whether C is 0 or C is not 0.
Hmm. Fight the urge famished. No chat GPT. This is saying that this is a determinant because it's matrix group action. I can sort of see if I think of the reciprocal part as a reflection.
I think it just comes to simplifying this down.
Yeah. CZ plus D. Yeah, if we bring CZ plus D here, right? CZ plus D.
Yeah, we could
My
bring that up to the numerator. You're right.
My pen's always too fat. How do I make my pen skinnier?
When you have the pen selected in the upper left, like the stroke width.
There it is.
So
CZ.
actually,
Because then these ADs will cancel.
yeah, and then we
ACZ minus B. We can factor a C and the C's will cancel. And this is, yeah, it's going to work.
yeah. So we would get what, like A times EZ plus D
Are we both writing it
minus.
out? We really
Oh,
are.
you're writing it out.
Yeah, no, you're good. Keep going.
Okay, okay. I'll keep going.
I didn't see that either.
And then here we just multiply the numerator, which I'm trying to think of it. Trying to do this in my head really quick.
Well, the ADs will cancel, right?
Yeah, ACZ plus BC
Yeah.
over C times CZ plus D.
Oh, nice. And the C will cancel.
Factor a C.
And then we can cancel the C's.
Andrew, yeah, I'm in the
AC
States.
plus B. Yeah, we got it. That's what we're
Equal
looking
to
for.
Awesome.
AC. Go.
Nice. And
Oh,
that's the C not
wait.
zero.
What if C is equal to 0? Because we can't.
We'd have a
Yeah,
separate
so
case to do
C-
there. Yeah.
So C equals 0.
That one's a lot simpler though.
Oh yeah, that's just a linear map. There's no inversion needed.
Yeah,
So
that's
we're
just good.
changing the
That kind of
third
maps
step.
it, or it matches immediately.
Yeah.
What were we saying, $10?
We're just changing the third step. So
Yeah.
still got 1 over CZ plus D.
I might say something slightly wrong here, but I'm recalling Penn Center last year when he taught the complex variables class on Twitch. He was describing this as like a series of transformations where like you have a stretch from the C times Z and then a translation from the plus D, and the reciprocal is a reflection or rotation. I couldn't remember what the R was, and then another stretch and another translation. There's some kind of really nice way of thinking about this in terms of transformations like that. I might have the exact thing a little bit wrong here, but I
Yeah.
think the geometric interpretation
So
of this.
that's a good thing. A lot of general Mobius transformations, which is this is basically the definition of a general Mobius transformation. You can always break it down into a sequence of geometric actions. So to actually break down and decompose a Mobius transformation, you do the linear shift in the scale. So when you have the denominator CZ plus D, you can say that that is Z1. The scaling is C and the shifting would be D. And that moves the origin and rotates and scales the plane. And the second thing is inversion. So Z2 would be 1 over Z1, which would flip the plane inside out, which we talked about, I think, before. I think you guys probably have a good understanding of that. And then the other linear shifts and scales, that's the whole thing that we did here with the negative delta over C times Z prime prime, which you could also say Z2, as I've been talking about. So say all this stuff, this is just being scaled and rotated by negative delta over C. And then the A over C is how much it shifts.
Right.
Here, it might be
Okay.
easier for me to break it down. So Z shift slash scale. Oh. CZ plus D, and then we have inversion, which would be 1 over CZ plus D, and then we have another shift or scale, which would be W equals AZ plus B over CZ plus D. Make sense? It's kind of like a map for it.
Yep. There's how Drago's complaining. But yeah, I think that makes sense.
I understand the first two steps very clearly. It's the third one that's a little bit confusing. But I understand, but I sort of understand it from what we did above. I mean, we showed that it is a shift and a scale, and the scale was with that determinant thing over C, and the shift was A over C. So yeah, I mean, I get it. We proved it.
Yeah. The third step, the reason why it probably feels a little bit off is because it's written in a form that looks pretty random, unless you know where it comes from. So when we're wondering like why those constants for 3, remember we've done Z prime equals CZ plus D, and then Z prime prime equals 1 over Z prime. So if you apply a linear map, which is just another scale and shift, that's how you get back to the original form. Here, maybe go even further down. Like if we have W equals A Z prime prime plus B, which is equal to A times 1 over CZ plus D plus B. That's where we would solve for A and B to make that match the original form.
Yeah.
And you could go through the entire solution if you wanted to.
Yeah, we could derive that. We could derive that and find out where that
But
determinant came from, I guess.
all you do is after you go through all this, you get to A equals BC minus AD over C, which you remember above we defined delta as this, which would be negative delta over C. And so that's where the map becomes W equals negative delta over C times Z prime prime, which is the 1 over CZ plus D plus A over C. Does that make sense? Where that comes from?
Yeah. Yep, looks good.
It's just about trying to match the original transformation.
Yeah. What we could have done, I mean, I think if we wanted to, what we could have done is from this step, we could have set this equal to what we had originally, right? And like written it as like we could have said, set this equal to AB plus C over CZ plus D. And then we could solve for capital A and capital B, right? In terms of the little letters. I think we would have got the same thing, right? It seems like that would have worked.
Yeah. The solving for the little letters, like, you mean like solving for A and B?
Solving for capital A and capital B as functions of the little a, B, C, D.
Oh, okay. Yeah, I see what you mean.
That's what I'm thinking of. Yeah. Then I would have understood it probably. I probably could have worked that out myself, but just sort of seeing it, I was like, oh, it was a bit of a mystery where it, how the
Where it comes
determinant
from?
popped up there. Yeah,
Yeah.
but I believe it. What I guess what I was saying for the most part was understanding that going from here to here was really a shift in a scale.
Yeah.
Just felt like, oh, really? Okay. It's kind of weird. But yeah, I get it. Yeah, it's cool.
Any other questions?
Wait, so you were saying something where like this last of us trying to get back to something. What are we trying to get back to? Or I understand, like, now I feel like I'm missing a piece where I feel like I wasn't before. Like, I was kind of assuming the weird form with the delta was kind of existing, but it sounds like there's more
So
reason for it that I missed.
when I was saying that, the intuition behind it, the intuition behind the final step is that we're doing a scale by negative delta over C to get the numerator right, and a shift by A over C to get the graph placed correctly. And that's what we're doing to match the original transformation. We're doing
So
those
the
things
thing
to
that's right here is
match
just
the
trying to
original
match
transformation.
like the thing that they originally gave, W equals AZ plus
Yes.
B. Okay. Okay, then I think I understand why we want to look for that number. Or okay, yeah. Connor, it was transformation by translation. Okay, yeah. Then Gianluca. Oh, nice. I hope your exam went well. Okay. So these normally run for about 2 hours. We're about the hour 37-minute mark. So we have time for a couple more problems, it looks like. But if anyone has to dip at any point, please do. No obligation to stay for the entire time. The last one I have selected from section 1.2 is number 12. No, Tessin. Not for a while. If we blaze through chapter 1, maybe we can skip straight forward to chapter 2, but I'm assuming we're gonna need at least one more meeting, or like one more meeting on chapter 1. I don't know if Hamish, that depends. Okay, show the circle in the z-plane corresponds to a circle in the sphere. Why didn't I get? I should have gotten a screenshot of the figure they're talking about. I don't know why I didn't. I'm looking for it.
Oh, I remember going through this when Penn Center was doing some of this stuff last year. And I think I was able to prove this.
I was thinking about this when I couldn't quite figure out I mean, I guess it's good to think about what a circle just in the complex plane is. That's the modulus of z minus some center is equal to a radius r.
Yeah.
And then we somehow want to plug that into the transformation. I'm getting the equations up. Wait, that's the inverse transformation. This is the forward.
So this question, is it just about having a better understanding of stereographic projection?
Yeah, it looks like why does a circle in the complex plane map to a circle in the Riemann sphere? I think is basically what it's asking.
Oh, there we go. Where z squared equals x squared plus y squared. Okay.
Um,
Yeah, I remember messing around with this for a while until I was able to prove it.
Yeah.
I'm sure there's a much nicer way to do it. I think I did everything in terms of X's and Y's and Z's.
that's where my mind is going.
I'm just thinking of proving it just geometrically, right? Just through intuition.
Yeah, like imagine if you're at the North Pole and you got a spotlight and you're going to shine it.
Right?
Hmm.
That's what. But now this.
You can see that it would make a you can see that it would make a circle. Well, can you? Let me think.
I mean, I was thinking the same like spotlight metaphor.
Yeah.
I guess the easiest way. I guess we should start with defining circles in the plane.
Yeah, I think the book was saying something about like intersecting a plane with a sphere.
What I'm thinking is we define how a circle would be in the plane, and then we use the projection equations for the equation of the plane circle. Like
Yeah.
let's say we have circle a x squared plus y squared plus bx plus cy plus d equals 0. And we want to map these points onto the sphere as xyz, then we can use projection equations, which are here.
Yeah.
But this, okay, I'm actually going to backtrack a bit here. I think it would be best to define the circle as x minus a squared plus y minus b squared, because then we can, or it equals r squared, because then we can expand this out a bit and we can get this x squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared equals 0. And then we can replace our x and our y with these.
Oh. So, or the the capital X, Y, and Z are the points on the sphere, though. We would want to the X in your thing, I assume, is the small X inside. I could get the other direction.
No, I mean, like, there we have these little x, little y in here, and we could solve for those.
Oh yeah, I think to save work though, I think it just comes out to be put off to the right. I think that's just the reverse direction there.
Where does our z go?
Well, on the plane,
Wait, it's weird because it maps it. two-dimensional point to a three-dimensional
'Cause-
point.
Because what I was thinking of replacing is I was thinking of replacing x equals big X times absolute value z squared plus 4 over 4. I was thinking
Okay.
of doing this instead, where
I
we
guess we can
solve
try
in this
that.
equation for x. We could try out both cases.
I don't know what I'm really expecting either way. I mean, it seems like a problem to have the small, like the complex number z be involved in the final result, though.
Yeah, because if you put this capital Z in your equation
I
here,
guess it's just the modulus.
it shows up in the denominators. I don't know if that's just a quicker way to do it. I think it's the same. It's the same thing.
I don't know. I actually don't know what they want us to do with these ones.
The question is, right? How do we even prove once we have these points, capital X, capital Y, capital Z as some kind of a set? How do we prove that it's actually a circle on the surface of the sphere? I remember having a lot of trouble doing that.
It's a good point.
I think I had to find sort of the normal that went through the center of it and show that they were all the same distance from some line coming out from the center of that unit sphere or that Riemann sphere.
I think if we get
You're
some,
saying in the book, Don, they said something about it being a plane, right? Like if you intersect a sphere with a plane, obviously you get a circle where they intersect. So is there a way we can prove that
yeah. So
all
it
those points are on a single plane, maybe?
it should look like if the equation for a sphere is x squared plus y squared plus z squared equals r squared, and the equation of a plane is ax plus by plus cz equals d. We could get these both equal to 0 and set them equal to each other, and we would expect whatever result we get to look like that, like the intersection of these two things. Like if we ended up with something that looked like this, I would think that we would have. The context might be a little bit weird. I would think that we would have proven it though, because that's the intersection of a sphere and a plane. It's minus d for how I did it. Like that's the type of result I would try to look for here.
Okay.
I don't have much of a plan for for getting there.
I like
mean-
what Josh was saying. I like what you guys are both saying. So we take the second set of equations that you pulled from the book, Don, and we plug those into Josh's formula here, right? Like plug these in here for this x, y, and z, and x and y. And then we could multiply everything by 2 minus z squared and clear the fractions and just see where it takes us. And maybe it'll get us to this thing this form you showed at the bottom here.
Yeah, I think that's fundamentally what I was thinking too. Like I was gonna start from like the modulus equation for like a circle with like z minus z naught. But I think this comes up. It'll come out to be the same thing as what Josh put here. I don't know. Let's just plug and see what happens.
I guess let's just go. See what happens.
Gotta make some room. I'm gonna shove this off to the right, I guess. So,
I still didn't put Discord on my iPad. I gotta try that. Gosh,
oh yeah,
So we're gonna sub equations from 1.2.27. So we're gonna have actually. So x squared plus y squared is going to be 2x
times-
squared over 2 minus z squared plus 2. Okay. This might be easier this way. 4x
Yeah,
squared plus I should probably 4x squared plus y squared over 2 minus z squared. And for the negative 2ax and negative 2by, we have minus 2a times 4a x over 2 minus z minus 4b y over 2 minus z.
Hey, Anders.
Actually,
Looks
we can simplify that a lot. Negative 4 times ax plus b y over 2 minus z.
okay, yeah.
And then
Just stays the same.
plus a squared plus b squared minus r squared equals 0.
And so I think we just have to multiply through by 2 minus z squared and hope our
Yeah,
cross
that's what I
terms
would-
cancel.
Yep. So then we have. Okay, I'm gonna get rid of this a squared plus b squared. So I'm gonna say a equals a squared plus b
Oh, yeah.
squared minus r squared.
nice.
So we're gonna
Why
have
don't we
a.
call it, we already have an A, so why don't we, oh, no, we don't have an A, do
We
we?
don't have
No.
an a.
We could
That's-
say that 4 times 8 does that too and divide out a. Or 4.
Well, I'm
17 is
thinking. I'm thinking. This is just if once we expand. 2 minus z. So we're gonna have 4a minus 4az az plus az squared plus 4, and then we cancel out the z or the 2 minus z squared, so it's going to be just 4x squared plus y squared.
Those are capitals,
Oh yeah,
but that's fine. We know what's going on.
x squared plus y squared minus. Okay, this one's going to be worse.
Yeah. Oh, that's right, because now we still have a lowercase a and b here.
Yeah,
Hmm.
okay, so I'm going to do just minus 8a x minus 8by plus 4a xz plus 4byz equals 0. This is a lot. This is a lot.
Oh, so where did the first 3 terms come from? I wasn't following that piece.
So the first 3 terms, I say
Yeah.
this is a, and then we have, when we multiply it out, so we have 2 minus z squared times, or sorry, times a, and then I just expanded it out.
Oh, okay. Thank you.
That's all.
I didn't realize you did that part first. Okay. I'm just checking the rest of the work. 2 minus C. Okay, yeah. Now this isn't as obviously canceling as I hoped. Or
No. I'm trying to.
annoying. It's
I
the
don't know. Are we on the
those are the
right track
problem.
or not? Or
Because we've got X times Z and Y times Z, don't we? We got to deal with that.
we could just intersect with the sphere from here and see if we get some eliminations there.
From where?
Just intersect this with the unit sphere. So, like x squared plus y squared plus z minus 1 squared equals 1. And try to see if we can eliminate some x squared plus y squareds from equation up here. Are we even on the right track? This is going kind of out of hand.
Yeah.
I'm gonna read chat, see if anybody's.
Yeah, the problem is the form that Don was looking for, we didn't have any cross, X times Y or X times Z or Y times Z.
Yeah.
So how do we fix that? I mean, the way you wrote it, Don, is general. I mean, that's just general, right? I mean, the x squared plus y squared plus z squared is r squared. That's the sphere. And ax plus by plus cz equals d, that's any plane. So that's just general.
Can we see that
Set them both to 0, set them equal.
a squared plus b squared minus r squared is equal to something else that cancels this? That's what I'm looking for. I really feel like this should have worked.
I don't see any algebraic errors.
Me neither.
And this is so long. Usually these kinds of problems, they don't get this expanded out. Things tend to
Oh
get
boy, I mean, I had
different.
a lot of fun playing with this problem, 6 months ago. I remember I did several pages. I was just playing around with it over a few days. And like I said, I'm sure I did not find an elegant way to do it.
Slim is
But it
saying
definitely
something.
took me several pages of messing around.
I think it's easier to see
Probably
a set of
several
points
false starts.
for the circle maps to something of the form. Is that the form for the intersection of a sphere and a plane? Slit.
Is it?
I guess I could, well, I don't know if I can buy that. Why would the Z not be squared? Okay, I guess it shouldn't be, or, hmm. I did make a slight mistake with my general thing. I should have done Z minus 1 squared. Make sure it's the actual Riemann sphere, but that's not going to fix our issues. Fibonacci node is in the Riemann sphere. Yes, I'm not sure where the second equation you put slim is coming from, or like, I don't know what it is. Like, I assume it has to be that circle on the Riemann sphere, but I don't see where it comes from. Oh, well, there's no squared for the Z term. That's what was confusing me. Oh, okay, that's just a typo then. Okay, okay, I was reading way too much into that. But I'm not sure, like, I feel like that's what we were trying to do, but we either made a mistake somewhere, or, like, we must have made a mistake somewhere. Either we set something up wrong, or we made a mistake on the way, but I don't see either of those things. Or I don't see mistake anywhere. Hmm. How annoying. No worries, Slim. Yeah, we are just about at the 2-hour mark. We could call this homework, or we could circle back around to it another time.
I'm honestly ready to throw my hands up and just attempt it tomorrow with a fresh mind because
Yeah, I want to.
I'm completely stumped, honestly.
I want to see if I can dig out the notes I wrote last year, if I still have them somewhere, and see what I did.
Yeah, I might mess it for myself. Just try starting from like a different spot or something, just seeing if I can happen to do it correctly.
It was great fun. Gosh, I had fun with this problem anyway. No, I did. It was a beautiful problem.
Okay.
It kept me entertained for at least a couple days.
Awesome. Yeah, I guess
you can prove that
oh, go on.
any sphere, any circle on the plane maps to a circle on the sphere, and vice versa, and any line in the plane maps to a circle on the sphere.
Yeah, that was another one. I skipped over that one because the circle thing seemed more interesting, but It might
I
be
think the
worth going
lines
back
were
and
way
doing
easier
that
to
one.
improve. I got the lines ones worked out pretty quickly, but the circles ones took me a couple days.
Yeah, and this one has an even number, so we don't have an answer, even if we
Now
wanted
we'll get it.
to look at it. Yeah. Um, yeah, I think maybe we'll call it here for the day.
Okay.
Because that was the last one I chose from section 1.2 anyway, so when we meet back again, we can get through section 1.3. And then the next meeting after that will be chapter 2.
So I guess we'll leave this as homework. I'll make a really good attempt. If I have a really elegant solution to this, then I will let you know.
Sounds good. Yeah. Please do, like, either on stream or in that like text chat for the reading group would be great.
Yeah.
By the way, it's good to meet you, Josh. What's your like Twitch name, or I assume you have an account there?
I'm deconcentrated in
Oh,
the
nice.
Twitch chat.
Okay, welcome in.
Just typed.
It was good to have you here. And from us, as always.
This is fun. Yep.
Yeah. All right. Next week is I realize that the meeting for next week might be up in the air. I might need to cancel it, but we'll certainly meet the week after next, if not sooner. So
Okay.
I'll let you guys know in the Discord.
Sounds good.
But all right, I'll see you all later.
All right. Yep. See you guys.
Thanks for being here.
See ya.
Bye. Okay. Noish. Let me get some music going. We'll do math for a little bit. Just gonna bring up this scene as I swap things over. Oh wait, I'm still in the math category. No, no. I'm doing everything wrong. Okay, that's the Twitch updated. Let me update YouTube. Why can't I? There we go. I can't even highlight text right. I want that thumbnail. Okay. Josh posting the VOD. Yeah, so my VODs go up automatically. Twitch will only save them for maybe 2 weeks or so. YouTube, I dual stream to YouTube though, and those stay up forever. And so I'm gonna put them into a playlist. And the actual Excel draw that we have here, I'm posting into the Discord as well as an image. Section 2. Next time we'll move on to section 3, then to chapter 2. Sweet. Full Factorio is not coming, or Daisy. What if I did? Would that be the end of the world? Okay. Eh. Okay. Um, I kind of think about number 11 now. The one about straight lines. I don't think they even do Cauchy Riemann in 1.3. I've read through it. They only talk about um this is kind of all they do with derivatives and the properties that follow. Oh yeah, Slim. Matthew point was very important difference between differentiation R2 and C. How if you want to differentiate C, end up with a bunch of extra restrictions. Be more clear in chapter 2. Okay. So, first off, what the heck is a straight line on the z-plane? That'd be something like w equals az plus b. And we would want to map that. So I assume the idea, like, this should be a lot easier. I need to get the same mapping things. For an article on Cauchy Riemann, could I ask for a critique of it? Like, David, this article is shit, but in more words. You have a cool approach to it from Jacobians. I need to practice my article writing skills. I would read it and give you my thoughts if you want. I've only barely been introduced to them, so if you want the perspective of someone with that skill level, then sure. I definitely would. A and B are complex numbers. Well, I guess, does that matter? I guess they can be real. Well, what the hell does this even mean? Not the more I think about it. Yeah, I mean, there might be people in chat who would volunteer to read it too. Yeah, I remember something about like partial derivatives, or like you take the limit along certain paths and you get two different, both the real and imaginary parts. I vaguely remember it from what Penn Center did, but I plan to do summer math expedition. I wasn't planning to, no, Slim. I haven't really looked into it for myself. Or like I know what it actually is. I just know it's run by three blue, one brown. I wasn't particularly planning to look into it though. Will I do hardcore complex analysis after? No, this is basically me cramming for grad school. I'm trying to get through chapter 4 of that book, and hopefully I'll be prepared for the class that I'm gonna have to take. Being a reviewer too is a bad thing? Oh. Is that like an academia joke? I need to think about what the hell this equation actually means before I can answer number 11. So I'm this inexperienced with the complex numbers. If I have W equals 2Z plus, the thing we're up by is, do A and B, do they have to be real? If they're complex, can only be boiled down to real numbers? Uh, 3 plus I. How about that? It's too many parentheses. But like, this is B, this is A. Like, the mapping is weird because you can't really graph things easily. Okay, yeah, I think what is this doing? I feel like it should be purely real now. Reviewer to academia. I'm intentionally not showing this. I feel like something weird is going to show up. Oh, okay. Never mind. This is Reviewer 2. Reviewer 2 is an angry and bitter scholar exacting revenge on their peers through overly critical, anonymous rejection of papers they secretly wish they would have written. Reviewer 2 does not like puppies. Don't be like Reviewer 2. Why is it Reviewer 2? Is there something special? Is Reviewer 1 not anonymous or something? You can type all the walls of text you want, FizzBuzz. Derivatives are purely formal. Or Wertinger derivatives are purely formal. Something wrong with me. So as Jacobians. Okay. It's always Reviewer 2, both are not. Oh, okay, it's just me. It's always Reviewer 2 who's like the harsh one. I generally, the only experience I have with it is I was a research assistant for a professor towards the end of my undergrad degree. And I remember seeing her and another professor she was collaborating with that, and I was helping them both, like basically shopping their paper around trying to get it published. And yeah, the peer reviews were not kind. I feel like there were 3 reviewers though, and they were all equally like dickheads. Oh, I'm glad to hear it. $10. It feels a lot easier to choose problems for complex analysis than for freaking relativity. Like I have way more of an idea of what it would kind of do. An ass not harsh. I don't know their exact comments, but yeah, they definitely don't pull any punches. Usually there's 3. Okay. What am I doing? But you know what? Fuck this. Let's just go straight to the fancy math. Who cares about knowing things fundamentally? What am I doing here? I'm gonna say x plus iy plus b. Then we're gonna presumably get the real part in the imaginary part. What am I doing? What am I doing? Why did this feel this? Okay. I don't think we want the intercept now that I think about it. Or a straight line on the complex plane should correspond to a great circle on the sphere. What the thought that just went through my head is if we have a y-intercept. Well, no, that doesn't make sense. I'm thinking about this. I'm thinking about this too much in terms of real numbers. Hey, welcome back, Inarid. Oh, I need to take down that pin. It might just be a mediocre circle. Like it should map to. I mean, does a great circle? It's a great circle. Do I just not know what a great circle is? Oh, not okay. No, it's not a great circle. Just some type of circle. Yeah, Enter. That was a Discord call. Circle of a less eminent stature. How's that different from the problem we were just doing, though? Like, why would a line and a circle map to basically the same thing? Well, I guess a circle would be constricted. Well, does it have to be? I don't know, man. How many sides does a great circle have? And I think it's infinitely many, Joseph. Lines are circles of infinite radius. My issues right now is I don't know what the hell a line in the complex plane looks like. Any straight lines on the z plane. Am I overthinking this? I'm thinking of like a linear transformation. That's not even a linear transformation. But like, I think maybe that's the wrong thing to think about. I think it's more simple than I'm making it. I think I just draw a freaking straight line like there. I don't know what the hell this... I don't know what numbers go here yet. But yeah, I can definitely see how it would wrap around to like... some type of circle there. It should always go through the point of infinity, I guess. Hey, narrator. What does this line look like, though? That's what I don't get. Hey, Pyro. Or like... What is that? It's going good. Thanks for asking. How about you? Inside and outside? That's a good point, Jasu. I mean, yeah, Joseph. It depends on the space you're in. Why am I feeling stupid here? Is this what topology is really about? I have no clue. I feel like I'm out of brain power for the day already, guys. I'm gonna be honest. This should be really simple and straightforward, and I'm getting confused. So should I be thinking of it as like z is equal to x plus I and then some like ax plus b is what y would be for a line? Like it's all points of this form. I might be cooking too hard here. Oh, Pyro, I didn't even see that. You could also use the z equals r cosine x plus I sine x, r giving you the radii. Maybe? Polar equation of trailing in polar coordinates. Maybe. It's like a line of constant theta if it goes through the origin, I guess. When is the graph of a function decreasing? Normally I'd say when the derivative is negative. Or sorry, when the second derivative is negative. No, wait, that's kind of I feel like I need the more exact wording there for that question, Doc. But yeah, if it's JE Advanced, I probably can't do it. I'm terrible at JE Advanced. If the second derivative is negative, it usually means that you're decreasing, I guess. But you can also ask about like acceleration and slowing down and speeding up, and that's where I was getting confused. Wait, do you figure skate, Joseph? That's news. Okay, I don't know how you justify this mathematically. I can visually see that it should be some type of circle that goes to the point at infinity. I don't know how you like actually get that mathematically. Doc, I can't. I don't know anything about the JE Advanced, so I don't know what the good resources are. There might be someone around who knows, but I don't know. The way these found these equations was pretty clever. I don't think I've heard of the Chebyshev inequality. A straight line corresponds to a circle passing through the North Pole. Okay. So I was saying that part, right? I don't know how you like... Are they only considering straight lines that go through the origin? That would make life a lot easier. Okay. Even if it's not what any arbitrary line. Okay. Sure, they only say describe. They don't say actually find it, but I want to find it. Okay, but if I just have a purely real number, like what do we get? Like I need to see something simple, I think. That doesn't make any sense. If it's a, I was just doing it for a purely real number. So it'd be like root x squared plus y squared. But I was just making y be 0. Oh wait, I would need a squared. No, I wouldn't. Yes, I would. Oh my god. Um, I'm still kind of confused though. Uh, how to go from this to the equation of a great circle? Well, this is just going to be circling the xz plane. Or at least that's what I would expect for this to be. I don't know how you... I don't know what to expect. Like, that's my issue. Ugh. My brain feels kind of numb right now, if I'm being honest. I think I just shouldn't work on this problem right now. Spetri, what's my favorite Greek letter? It's a good question. I feel like I have them, but now it's not coming to mind. Because I'm just brain dead right now, I think. It's definitely not Kasai, I can tell you that much. Gamma is fun. I do like lowercase gamma. You like gamma too? I think we like different gammas, though. I feel like you usually draw the other gamma, right? Oh, lambda. No, I think I'm going lambda. Mostly because of Half-Life. Both sigmas are goated in small pi also. Capital sigma is so annoying to draw. Lowercase sigma, yeah. I like that. Pyro like psi. But no, we do different lowercase gammas. I think Fembox, like, hot stretchy. Did I figure out what does that? I figured out what makes it stretchy, I think. Or did I? Such just a coincidence. I might have figured out what makes it stretchy. But no, I like that gamma, but I feel like Finlux usually write that gamma. Chi and Phi because they're easy to write. You have personal beef with Chi, Spetri? I only know of Chi from statistics. Why do you have beef with Chi? Pi versus Chi is not easy to write. Chi is, that's how I write Chi, squiggly X. Your game is a dying fish. This game just feels so fancy to me, that's why I like it. It's like the little saw. Nuke? I don't know. You can't see the difference between your Kai and your Kasai's? What? Those are completely different. That's Kai. That's Kasai. They're even close. How much my game looks like my Kai? Oh, I mean, I was being... they do look really similar. I was also being lazy and not... I should draw it. It's basically... I make it squiggly X. My Kai. Doomwood, your stats exam? Ooh, I hope it went well. Oh, just your regular X's. Yeah, okay. Sorry, I know what you mean now. Yeah, they're basically the same thing. Oh, Omega is pretty fun too. It's not my favorite, but like both Omegas deserve an honorable mention here. I do enjoy drawing small Tau as well. Because with small Omega is W, that's fair. Yeah, personal beef with Omega. Big Omega deserves a kiss on the cheek. Who makes that Sigma? Oh my god. If you do that Sigma, I think there's something wrong with you. Grandpa's hole's pretty smashing. Yeah. Creative and unique using a mic stick and A equals awkward symbol. At the start of my working to avoid them. I would love to do that with Kasai. I never want to write Kasai. The Fourier F? Oh yeah, that's a good one to do it too. Small Tau is B+, yeah. I like small Tau. Joseph. That's kind of the strategy I was going for. But the issue is I don't see how that result maps to a great circle on the sphere. That's what I don't... That's where I got stuck. Sorry, Nort. We're just talking about Greek letters, I guess. There's not much to understand there. I was working on this problem before, but I'm kind of stuck on it. So, you know, the one doesn't understand things. But yeah, like that's where I was gonna start, Joseph. Or like, there should be a relationship among all of these, but I don't know. Once I do that, I don't know where to go after. Is my issue. Yeah, Spetri. I figured out a way to do it. Yeah, as long as YouTube isn't like consistently being degenerate, which they haven't since I've been doing this. We'll keep it going. Well, the unfortunate thing is if I delete a message on YouTube, or I think even on Twitch, I don't think that gets deleted in that chat. So we'd have to like spam or something if it's a problematic message. I never did complete this general relativity problem. I don't think I have the brain power to do it right now, though. I wonder if I should just call it, because I don't think I have the brain power to do much right now. I can just feel it in my head. Straight lines and circles in a plane all map to circles on the Riemann sphere. Yeah, Joseph, and they all go through the point at infinity, I think. It's like I know visually what to expect. I don't know what the equation for circles like that are, which is part of my struggle. Doomwood, I mean, that kind of depends on you and what you're interested in. I have a hard time just kind of like saying that. Like, you're doing stats, like what else, like what's the last thing that you've studied? Like, yeah, if you haven't done calculus, that will be like the #1 thing if you haven't done calculus already. Something you remember from fall semester, yeah. Calculus, stats, and mechanics. Yeah, I would say 100% calculus, because that can be used in both stats and in mechanics, and you can do a bunch of really cool stuff if you know calculus. Calculus in general is just awesome. It's really foundational to just so many things in life. The Holy Trinity except for stats. I mean, well, that's the holy duo then, if you're only saying calculus and mechanics. I think stats is a really cool area of math. I don't like AP stats or like, high school level stats. But the theory of statistics and using calculus and stuff, I think is kind of sick. Speaking of mechanics, I'm going to be a TF next academic year. Now you're scared. Is that... It's not Twisted Fate from League of Legends. Teachers fan? I assume it's like a TA. Teaching fellow, okay. Nice. For mechanics, that's awesome. Dude, I'd love to do something like that. The dynamic duo. Mathematical statistics can be pretty fun. I think so too, yeah. Holy duo curse solo. Basically a TA. Awesome. That's a great opportunity. Yeah, okay, I think I have an issue, guys. Like, I don't have any brain power to do any more math today, I feel like. And I have to tutor someone in a few hours. I know, it's kind of either I sit here and yap, or I just kind of call it. What am I tutoring? Calculus student who's learning freaking power series. He was given a bunch of challenge problems. Or it's like challenge for like a a calculus student. Rubik's Cube? All right, we can do Rubik's Cube. It's me. All right, scramble it. All right, inspection time. Oh God. I Bro, I'm wasting so much time right now. Oh, what the fuck perm is this? Oh, G perm. I'm gonna fuck this one up. Terrible. Terrible. I got a permutation that I'm rusty on. Absence of a tutor, am I? I live in a very different part of the country. People charge like I charge like $30 an hour. Someone if you want to get tutoring from someone with like a PhD or someone who's like super qualified, it's easily over $100 an hour. So I'm at the lower end of the spectrum, at least if you look at it like that. It's really just like a friend of a friend who I'm tutoring. He's local to me, but we just do it over Discord. Kung, I don't know if courses on YouTube to study complex numbers. I'm sure they're out there. I bet you MIT OpenCourseWare has one. MIT OCW complex analysis. Yeah, this is probably it. It's like I haven't looked at this exact one, but I followed along with their linear algebra. This is in black and white? How old is this? Wait, I just have to see what this looks like. No, this is a little, okay, I think it's a little bit. There's no way this was that old. I feel like they just made it look old. That's what I feel like. It's slim. Kug, I don't have a specific recommendation. I would just look up complex analysis lectures and go from there. To be honest, I haven't looked at one for myself, so I don't really know. Folks used to charge $20 an hour than a private tutoring. Yeah, I mean, I was like when I worked in a community college as a tutor, they paid me like $18 an hour. And so when people would ask me if I could tutor them privately, I just say like, I just tell them 20. But at least around here, that's kind of crazy cheap for a private tutor. Like, if I actually like registered on the website to tutor people privately, I bet I could get away with charging more than that, like more than 30 even. Um, Okay. I think that maybe I'm just gonna call it because I can just feel myself getting more and more tired. So yeah, people here on YouTube, thanks for being here. I'll be back on Thursday. So goodbye, YouTube.